So, not long ago, I saw this comment from the one who knows everything, and there are two pretty good questions right here that I will go through in this video, and this is for Core 4. So first, let's take a look at the January 2009 paper, the first question on section B, which is question 7. So just by looking at this question, it looks to me like a differential equation sort of question, and scientists can estimate the time elapsed since an animal died by measuring its body temperature. So it would be a temperature change according to time, and assume the temperature go down at constant rate 1.5 degrees Fahrenheit per hour. Estimate how long it will take for the temperature to drop from that to that and that to that. So that is just a constant gradient function, which means the gradient is a constant decrease of 1.5, which is relatively simple to do. And the second bit, show integration of the solution, is that basically you want to find the solution to this differential equation using separation of variables. And part 3, find A and show that K is that. By using these initial values, practically you just substitute in all the values that you're given into this and solve a simultaneous equation. Part 4A and B, calculate how long the actual time for these two are, because it's now a decay curve instead of a straight line curve. And comment on the result of part 1 and part 4. Basically say the difference and similarities. So for the first bit, we need to find if it is a straight line, how long does it take? So basically we just want to find the amount of change in theta, divide that by every 1.5 to get the change in time. So the change on the first one is just 9 degrees Celsius, and I should have written Celsius, but I am lazy, so I didn't. So 9 degrees Celsius divided by every change of 1.5, and technically it is 89 minus 98, which is a minus 9, divided by the gradient, which is minus 1.5. But if you can see how to do this question, then you can ignore the negative sign because they do cancel out. So this will give you 6 hours for the first bit. Then for the second bit, you're dropping by 18 degrees, and every hour drops by 1.5, so that is 12 hours. So that's 2 marks for part 1. Okay, this bit, part 2, integration by separation of variable, because that's the only way you can do this question. So you have this expression, and we need to integrate this. So by separation of variable, divide both sides by theta minus theta naught. You get 1 over theta minus theta naught d theta, and multiply both sides by dt to get minus k dt. And because mathematicians love their integral signs, add that for them to make it, well, quote-unquote balanced. It really doesn't matter, to be honest. And in here, make sure that you know that theta naught is just a number. It's a constant. It doesn't change. Theta is the thing that changed. So because we're integrating a fraction and we have the integration variable at the bottom, if we differentiate the bottom and we get the top, then the integral of this whole thing is natural log of theta minus theta naught. plus a constant c. And over here, if we integrate a constant, then you get a constant with a variable. So you get minus k t plus another constant c. Let's say this is c1 and c2. And because those constants are just a number, you can add them up together without finding them. And let's say that c equals to c1 plus c2. And you can combine both of them on either side. It doesn't really matter, but the best choice is to go on the right because we have a natural log on the left. So ln of theta minus theta naught is equal to minus kt plus c. And if we e both sides, the natural log goes away. So theta minus theta naught is equal to e to the minus kt plus c. And by the log rule, or the power laws, that is the equivalent to e to the c multiplied by e to the minus kt equals to theta minus theta naught, and therefore e to the c, where c is a constant, e is also a constant, so they are a constant, and we denote that let a equals to e to the c, and therefore we get a e to the minus kt equals theta minus theta naught, and therefore theta is equal to a e to the minus kt plus theta naught, and that's the answer. Okay, so now that we have this equation that we derived, we can use the initial conditions over here to find a and find k. And for this step, you'll need a calculator. So go find your closest calculator. And let's start with theta at t equals 0. We know that theta is 98, so 98 is equal to a e to the 0, because minus k times 0 is 0, plus theta naught, which is 50 degrees. And by subtracting both sides by 50, we get a is 48. So that's quite simple. Now, in order to find kt, or find k specifically, you differentiate the expression, or you use the original expression, which I forgot. So I'll have a look, or I can just differentiate it, because that might be a bit easier for me. d theta by dt is equal to minus k a e to the minus kt plus nothing, and therefore this is theta minus theta naught. And because we know all these values, we can just literally put in all the numbers. So a e to minus kt according to, no, actually I want a e to minus kt because I want to find k. Or actually no, I have the minus k over here. So let's say that is theta minus theta naught. And as you might expect, there are more than one way of doing every single question of these. So you can use the easy methods, or you can use the difficult methods. It's all up to you. Theta minus theta naught, 98 minus 50 That's 48 again, and surprise, surprise, that's A for some reason. And the negative goes, and so K is 1.5 divided by 48, which gives us 1/32. The equivalent decimal is 0.03125. And usually I'll leave it as a fraction, but it's kind of good if it is a rounded fraction. You can put in the decimals. If it is some fraction that gives you ridiculous values, say 37 divided by 58, then just don't even bother. Just leave it as fraction, and they won't penalize you for anything. So now we have K and A. Move on to part 4. Okay, so let's use what we know to find out the change in time. So we know that t at 0 is 98, theta at t equals 0 is 98 degrees. So we know that we only need to find t that correspond to these two values. Let's do part A first. So 89 is equal to 48 e to the minus 1 over 32t plus 50, and that gives you 39 over 48 equals e to the minus 1 over 32t. I skipped one step because I just did it in my brain. And now we need to do a natural log of 39 divided by 48, which will give you a terrible number. Learn of that will give you a minus 0.27. Actually. 6. I'll just put 4 decimal in. Just keep your calculator value at all costs. 1 over 32t. Then you just multiply your answer by a negative 32. And that will get you your t equals to 6.64 hours. And if you remember, for part 1a, it is t equals 6 hours. So not that big of a difference. It's like about 33 minutes-ish. No, more than that. 37 probably-ish minutes. So that's not that much of a difference. Now look at B. For a time longer, it might deviate a bit more. So 98 to 80, we have 80 equals to 48 e to the minus 132 t plus 50. That gives you 30 over 48 equals to e to the minus 132 of t, and that will mean that 1 over 32 t's negative will be equal to the natural log of 30 divided by 48 is negative 0.47 and 3 zeros, surprisingly, and multiply that by negative 32 gives you t equals to 15.04 hours. And usually I leave it in 3 significant figures. Same for this one. So now let's do part 5 right here, because it's just a 1 marker, and compare the result of part 1 and part 4. So part 1, if you forgot, this is 6 hours, this is 12 hours. So the comparison right here is that for a small value of change in theta, this is 8 degrees, the deviation is small. It's just by 0.64 hours. But for a longer temperature difference, that is 18 degrees, the time difference increased exponentially into 3 hours. And remember, this is double in temperature decrease, but this change is slightly more than half an hour. This is 3 hours, so that is about 5 point something times. So that is a massive difference, massive deviation from its expected value for large t. So the conclusion for part 5 will be the model similar at low temperature differences. But have large difference at longer time periods. So that's pretty much it for this question. Now let's move on to the other paper and look at some other questions. So let's get on with the second question, which is from June 06. And it is again the first question on section B. This is question 6, and it is a parametric sort of question, and note that it has something to do with trigonometry, and it uses radians because any graphs use radians for its trigonometry. Find in terms of A the length of straight line OE, and well, this is basically finding the x coordinate of E because O is 0, 0. So for part B, max height of the arc, so you need to find the stationary point of this particular graph. Part 2 is find dy dx in terms of theta. Okay, you might need to use part 2 to do part 1b, but I think there might be another method, so I will leave that open. Straight line intersect straight line section ABCD inclined 30 degree to horizontal tangent to curve B and C, and parallel to x-axis, BF parallel to y-axis. Okay, show that point B parameter theta satisfies this. So basically you need to do something funny with the equation and just rearrange everything. Verify that theta is equal to 2/3 pi is a solution to this bit, which should be relatively easy to do. Hence show that BF is 3/2 A. Yeah, I can see how horrible this question actually looks like when you're in a panic mode. And find B, C, and AF in terms of A. B, C, and AF in terms of A. Given the straight line distance AD is 10 cm, calculate value of A. This question is just too big. Okay, so let's get right into this question, because let's not waste any time. Okay, let's start with part 1, find OE. we know that O is 0, 0 by definition, and so let's find E. What we know about E is that it have y coordinate 0, so we can equate 0 equals to 1 a times 1 minus cosine of theta. The a really doesn't matter right here, because 0 divided by a, where a is a constant, means that a is out of the equation. So all we need to do is find when cos theta equal to 1, because this bracket have to be 0. So 1 equals cos theta, and by either calculator or actually for radians, for most people you use a calculator because it's a bit more difficult, but cos of 1 is just 0 and 2 pi, which is also 360 degrees, because the cos graph looks sort of like this, and for cos to be 1 it has to be on the 0, 0, well, on the 0, 1, or on the 2 pi 1. So I've got two values of theta, which is sort of natural because it only crosses the y-axis twice. So which is which? Let's find out. So if I have theta is 0, then x will be a times 0 minus sine 0 is 0, which gives you 0, that is 0, 0, which is correspond to the origin. So instead of that point, we take 2 pi as our other valid answer. So x will be equal to a times 2 pi minus sine of 2 pi, which is also 0, and therefore you get that the x coordinate is 2a pi. So OE as a distance is just 2a pi subtract by 0, which gives you 2a pi. So that's part A. Now find the max height. I am highly inclined to do the differentiation of both of these to get the height, but given that the second part is finding the gradient, I do not think I shall do that, so I should use some other method. And let's see, in order for this, because this is a symmetric graph, I know that the x is halfway through this, so x is equal to a pi. And so by equating this equation with this equation, I know by just cancelling the a, pi is equal to theta minus sine theta. And let's see, can this be done this way? Kind of looks like I went into a slump. Don't think that works. Or let's see, I don't think so. Well then, I guess I'll need to go the differentiation route, because again, many different ways. I just thought like the easiest method for me is just differentiating. There are other solutions, there are other ways that you can do these, but right now for me my brain works only using differentiation, so let's do that. Dx by d theta is just a times theta differentiate to 1 minus sine, that goes to cos, and dy by d theta is equal to a times 1 goes to 0 minus cos goes to sine, and therefore by dy by dx, so it's the bottom divided by the top, you get a sine theta divided by a times 1 minus cos theta and you get that sine theta divided by 1 minus cos theta is 0, because it is at its maximum point, and this is dy by dx. And so we know that sine theta have to be 0, and naturally theta will have to be either 0, pi, or 2 pi. And by the things that we've done before, we know it's not 0 nor 2 pi. So we know that it is at pi that this happens. So put this parametric variable into y to get the max height. We get y equals a to the 1 minus cos pi. Cos pi is -1, so you get 2a. So that's the max height. Okay, now that I think about it, I know how to do it without differentiating. So let's see. This bit is part 2, and this is the answer for part 2. So I'm gonna skip part 2 later, but to find the max y, there's actually a even easier way. You do not even need the pi. You just need to look at this and say, okay, a is out of the equation, it doesn't matter, it's what in the bracket that matters. So 1 minus cos theta have to be as big as possible, and so it have to go to because cos theta is either +1 or -1 for it to be a maximum or minimum value. Let's see, if it is a +1, then it will be a 0 value, so it's not +1. It have to be a -1 then. If it's a -1, you get 2, and therefore by putting this 1 minus cos theta equals 2 into the equation, you get 2a as well. So that should be the one that they're aiming for, but I went the long route because I just can't think of it at the moment. Remember, every question have more than one way of doing it most of the time, especially for C3 and C4. Well, maybe less for C3, but there are multiple ways to go by every question. Do not waste time thinking about how they want you to do it. Do it your way. As long as you get the correct answer, you'll get the mark. So I'll go to part 3 next. Okay, so for this bit, this is a really horrible question because it have a lot of different angle units in it. This is in degree mode, this is in radian mode, and over the course of these steps you will need to switch back and forth, which I have never seen that before. So just make sure that you do read the question and do change your calculator angle unit as you go along, because those are the most likely downfall for most candidates, is that they forgot to change their angle units and they get horrible numbers. So right here, what all those information given to you in that passage is basically AB is the tangent of the curve at B, and therefore the gradient of AB is dy by dx, which is this expression. So sine theta over 1 minus cos theta is equal to the gradient of that. How do you find the gradient of a straight line? Well, literally change in y by change in x, or bf by af. And in trigonometry, we know that this is the opposite angle, this is the adjacent angle, and therefore we get a tangent expression. So tangent of 30 degree, not radians, degree, is this expression. And so because tangent of 30 is 1 over root 3 from our special angles, or if you do root 3 by 3, then you need to kind of irrationalize it, which doesn't make any sense, but anyway, you get the expression sine theta over 1 minus cos theta, and you multiply both sides by 1 minus cos theta, and you get the expression they want. That's straightforward. Now, turn your calculator back into radian mode after you've done all that hard work. You need to verify that theta is 2/3 of pi. Verify as of just find the answer to, like, see if it fits. So left hand side is sine of 2/3 pi, and sine of 2/3 pi is root 3 over 2. What about the right hand side? The right hand side is equal to 1 over root 3 multiplied by 1 minus the cosine of the same thing, which is negative a half, so that is add a half. Oh yeah, of course. My bad. This is 3/2, not 3. There you go. So this is 3/2 of 1 over root 3. Scrap that. I'll edit that bit that I just absolutely got stuck on, because that just looked absolutely poor. Now rationalize this, multiply top and bottom by root 3. You get 3 root 3 over 6, which is root 3 over 2. So you can say that LHS is equal to RHS. And if you're doing proving, you'll normally throw a QED down, but we're not really proving, we're verifying, so don't need that bit. Now find BF is 3/2 of A. Where's BF? B to F, that's the height of it. So basically we want to find the theta of this. So let's see, because I want to find y, and that's a times 1 minus cos theta, and I'm looking for the b coordinate, and we know that sine of the b no, this is actually c coordinate, isn't it? So this is not useful to us. Why is that? And we want to find let's see. So we know that 1 minus cos theta is equal to sine theta times root 3 according to this equation, because we just multiply root 3. then we know that y is a times root 3 sine theta. Wait, no. What am I talking about? Okay, this 2/3 pi is less than half pi, which corresponds to this. 2/3 pi is less than 1 pi, which corresponds to the top, the maximum. So this have to be on the left. So 2/3 pi is actually the coordinate of the parametric degree of B. So to find the BF, you just put y equals a times 1 minus cosine of 2/3 pi, and according to what we've done before, we know that is minus a half, so that is a times 1 plus a half, and this time I will not do the same mistake here, which is 3/2 this time, so 3/2a, same thing, and that's that bit done. Now find OF. OF can be found because we know we need to find the x coordinate of f, and we know what theta is. Theta is 2/3 pi, so x is equal to a times 2/3 pi subtract by sine 2/3 pi, which is root 3/2, and that look horrible. So that's 2/3 a pi minus root 3/2 a. So that's the length of OF, and that is finally part 3 done. Okay, so finally we want to find BC and AF, and also given that AD is 20, find A. And these are all the lengths, and well, yeah, all the lengths that were found in our previous parts. So let's take a look. In order to find BC, we need to get the coordinate of OE subtract by 2 lots of OFs, because this length is the same as this length, and so 2a pi subtracted by 2 lots of 2/3 a pi minus root 3/2a is 2 lots of that is 4/3, so 2 minus 4/3 is 2/3 a pi's, add, because negative negative, root 3 of a, so that is BC. And AF is just normal trigonometry. Go back to degree mode again. Let's see. Degree mode, tangent of 30 is just actually that's BF divided by AF. We want to find AF. We know BF is 3/2a's, and we know tan 30 is 1/root 3 over root 3/3. So 3/2a, and just multiply AF to the left, you get AF times this equals to that, and so you know that AF by multiplying by root 3 is 3/3/2a's. And finally, given that A to D is 20 is equal to AF, no, actually, yeah, AF plus BC plus another AF, so 2 AFs, which is 3 root 3 A's plus BC. So BC, as we have found, is 2/3 A pi plus root 3A is equal to 20. Now I can factorize the A out to get 3 root 3 plus 2/3 pi plus root 3 equals 20, and put them all into the calculator because I do not want to do that in my heart. It would be really difficult, to be honest. I can't do that. I can't do surds in my heart, really. And that gives us 20 divided by 0.9 something, 9.023. So A is 2.216. So 3SF is 2.22. So that's it for this question, and also for this video, because I was asked to do 2 and I've been pretty busy lately. So I'll end it off here. If you've learned something, then tell me in the comment section below. And I've been lacklustering for the last part 3, because my brain just didn't function at all. So tell me your feedbacks and I'll work on it. Thank you very much for watching, and I'll see you next time.